Ever messaged a friend across the globe? Think about that for a moment. The ability to instantly connect with someone on the other side of the planet is truly remarkable. Or watched a video from another continent, perhaps a live concert from Europe, or a news report from Asia? It feels instant, almost magical, a seamless flow of information connecting us all. But this connection isn't magic. There's no mystical force at play here. It's a vast physical network, a complex web of infrastructure, linking billions of people together in real time. When you send an email from New York to Tokyo, it takes a real journey through an incredible infrastructure of cables, servers, and routers. A journey that spans thousands of miles in a fraction of a second. The internet is a library, holding a wealth of information at your fingertips. It's a post office, delivering messages instantly, a movie theater, streaming entertainment on demand, and classroom all in one. A dynamic and ever-evolving space for learning and growth. It lets a student in South Africa learn from a US university, accessing knowledge and opportunities previously unavailable. Or a grandparent in Italy watch their grandchild in Australia, bridging geographical distances with a simple video call. For all this to happen, data must travel reliably and at lightning speed, ensuring a seamless user experience. So, how does a cat video get from Europe, from someone's home or office, to your phone in South America? What path does it take to reach you? It's not floating in the clouds or beaming from space, not usually. While satellites do play a role, they aren't the primary method. Most of the internet travels through a hidden network deep beneath our oceans, a vast and largely unseen infrastructure. This system is both strong, capable of handling massive amounts of data, and surprisingly fragile, vulnerable to damage from natural disasters and human activity. Let's dive in and explore this unseen world and uncover the secrets of the internet's underwater backbone. Many think the internet is wireless, thanks to Wi-Fi and cellular data. But over 99% of international internet traffic travels through submarine cables on the ocean floor. These cables stretch for thousands of miles, carrying your emails, video calls, and favorite shows. Why cables, not satellites? Speed and capacity. Light travels faster through fiber than to a satellite and back, which means less delay. Cables can transmit terabits of data per second, far more than satellites. The first transatlantic cable was laid in 1858. Today's fiber optic cables are its high-tech descendants. They send data as pulses of light through glass fibers at incredible speeds. So, next time you connect overseas, remember, your data is racing through cables deep under the sea. Have you ever wondered what lies beneath the ocean's surface, facilitating our instant global communication? What do these vital undersea cables actually look like? In the deep ocean far from the shore where they rest on the seabed, they're often surprisingly no thicker than a garden hose. It's incredible to think that such a slender tube carries so much data. At their core, the very heart of these cables are ultra-thin glass fibers, thinner than a human hair. These delicate strands are the key to transmitting information across vast distances. They work by carrying information as laser light, pulses of light that travel at incredible speeds. This allows for near instantaneous communication across continents. These fragile fibers are protected by layers, multiple layers of specialized materials designed to withstand the harsh marine environment. First, a gel, a special compound that cushions the fibers and prevents water from seeping in. Then, metal tubes providing a rigid barrier against pressure and potential damage. Next, polycarbonate, a tough plastic that adds another layer of insulation and protection. Followed by aluminum and steel wires providing strength and shielding against external forces. Deep sea cables have a plastic sheath, a final outer layer that protects everything inside. Near the coast, where the risk of damage is higher, they're armored with steel and tar for extra protection. This heavy armor is essential in shallow waters. This armor shields them from fishing nets, anchors, and other hazards, including the occasional curious shark. Inside, cables also carry power for repeaters, devices that boost the light signal every 70 to 100 kilometers. These repeaters are crucial for maintaining signal strength over long distances. Repeaters keep data moving strong across vast distances, ensuring that your cat videos arrive without a hitch. Electricity for these repeaters travels down the cable from landing stations located on shore. It's a marvel of engineering data and power, all in one slender package, a testament to human ingenuity. These cables are built to survive crushing pressure and constant threats. They are truly resilient pieces of technology. Without them, our global internet wouldn't exist. We'd be living in a very different, much less connected world. That's the hidden magic beneath the waves. the unsung heroes of the internet age. Laying these cables is a massive job, a truly monumental undertaking that requires careful planning and specialized equipment. It's not just about dropping a wire into the ocean. It's about creating a reliable, long-lasting connection across vast distances. This complex task is handled by specialized cable-laying ships, vessels specifically designed and equipped for this unique purpose. These ships are floating factories, capable of managing and deploying thousands of kilometers of delicate cable. These ships carry thousands of kilometers of cable, meticulously coiled and ready to be laid across the ocean floor. The sheer volume of cable is staggering, representing a significant investment in global communication infrastructure. The cable is loaded with precision, ensuring that it's free from any damage or stress that could compromise its integrity. Every meter of cable is valuable and must be handled with the utmost care. Before setting sail, dedicated teams meticulously map the ocean floor, using sonar and other advanced technologies. They do this to find the safest, flattest route, avoiding underwater mountains, trenches, and other obstacles that could damage the cable. The goal is to minimize stress and ensure the cable's longevity. This detailed planning can take a year or more, involving extensive surveys and complex engineering calculations. It's like building a highway at the bottom of the sea, a carefully designed and meticulously constructed path for data to travel across the globe. The ship starts at a coastal landing station, a critical point where the submarine cable connects to the land-based network. Here, skilled technicians carefully connect the cable, ensuring a seamless transition between the underwater and terrestrial infrastructure. Then, the ship slowly unspools it out to sea, a continuous process that can take weeks to complete. In shallow water, where the risk of damage from fishing trawlers and anchors is higher, a specialized plow buries the cable beneath the seabed for added protection. This ensures the longevity of the cable. However, in deep water, where the seabed is relatively undisturbed, it's laid directly on the ocean floor, relying on its weight and the surrounding environment for stability. The ship moves at a steady, carefully controlled pace, maintaining the correct tension and avoiding any sudden movements that could damage the cable. This meticulous process continues, laying cable for weeks or even months, until the entire route is complete. Throughout the entire operation, highly trained crews monitor every detail, using sophisticated sensors and software. They keep a close watch on cable tension, depth, and position to avoid snapping or kinking the cable, ensuring a smooth and reliable deployment. It's a slow, precise operation, demanding expertise, patience, and unwavering attention to detail. Ultimately, this painstaking process results in stretching a lifeline of communication across the ocean, enabling the seamless flow of information that connects our world. This is how the world stays connected, through a vast network of underwater cables that form the backbone of the internet and global communications. Once laid, cables face many threats, mostly from humans. Fishing trawlers and ship anchors cause most cable faults, especially near the coast. That's why cables are buried in shallow waters. Natural disasters like undersea earthquakes and landslides can snap cables too. Volcanic activity and even rare shark bites have damaged cables. Modern cables include shark-resistant layers where needed. Cable owners publish maps and monitor cables 24/7 for breaks. When a problem is detected, repair crews spring into action. These cables are built to last decades, but constant vigilance is required. Protecting them keeps our world connected. Even with protection, cables sometimes break. Most countries have multiple cables, so traffic is rerouted like taking a detour when a highway closes. But for remote places with only one or two cables, a break can mean total isolation. Engineers use pulses of light to pinpoint the break's location with precision. Repair ships retrieve the broken cable from the seabed, splice in a new section, and restore the link. Splicing is delicate work. Each glass fiber must be perfectly aligned. Repairs can take days or weeks depending on conditions. It's a tough, expensive job, but vital for keeping the world online. The global network depends on these rapid repairs. Undersea cables are the invisible backbone of our digital lives. They power everything from global finance to family video calls. As our need for data grows, new cables are being laid with even greater capacity. These cables are owned by international partnerships, showing what global cooperation can achieve. The internet isn't an abstract cloud. It's a physical network built by human ingenuity. Next time you stream a movie or call someone far away, imagine your data racing as light through a hair-thin fiber on the ocean floor. It's one of the greatest engineering marvels of our time. The internet is science, not magic. and it's truly awesome. Consider this.